So why do we need this OSI layer? Anyone can tell me?
It's literally what we use to transfer data.
Okay.
From,
And
oh, sorry. I wanted to add that, from my understanding, is a standard that they put in place so that we can have many constructor of
you're
art.
right. You're right. For example, if I open one company, which basically creating or developing some kind of Ethernet network interface adapters, it's a manufacturer company. And then I have to follow some kind of standards, okay, which is governed by ISO, International Standard Organization. It is a governing body. Okay, it will develop some rules and regulations for the rest of the people who are going to manufacture these devices, like switches, routers, network interface card, even the cables, the fiber optic cables. So they have to follow. So this is the governing body who basically govern this OSI layer model for everyone to follow. So this is basically it. Okay.
That's like if you have even a television with the Ethernet, right? And you want to plug that in, that Ethernet has to follow some type of standards, which we're talking about the ISO and OSI layers. So, it's going to get an IP address. It's going to understand what my phone is going to tell this Ethernet that is going to be connected to that TV. So that's it. It can be anything. Exactly. It's just a standard that we need to follow. And that's why this layering is used, that we can put it into other devices. It's not just router or switches, it's everything. And they have to talk to each other. For that, they have to use some type of standard. And that's why we need this type of layering approach.
Exactly. So let's talk about OSI layer in detail with this one example. In the next slide, I will show you the animation as well. So it will clear your concept. So here we have the transmitter, or you can call it sender. And then here we have a receiver. And what sender and receiver means, basically, this is your computer or host machine, and you type www.google.com. And what is going to happen? Because this is going to go somewhere in the server of Google, which is a receiver. So this is a server located somewhere in a far location. And these are the things going to happen during our communication. And what those things are, it is going to go through. First of all, it will hit the application layer, presentation, and session. These usually all comes under a same layer. But just for the clarification purpose, we are going to make it a separate, so you have a better idea what is it. Application layer, all kind of your applications, World Wide Web, your HTTP traffic, which is not secure, HTTPS traffic, which is secure. Then we have some other multiple applications being run on application layer, like we have FTP, file transfer protocol. We have SMTP, which is used for the mail exchange, for the emails conversation, basically. Then we have Telnet. We have so many applications running on an application layer. So whatever the input you are going to do will be done from the application layer. So this is going to be your entry point. So let's suppose you type www.google.com on your web browser. It is going to happen on your application layer with the help of web browser. Okay, so the web browser works on application layer. And this is going to be your 7th layer. Not to confuse that this is A or application layer. So it starts from first layer. This is also a very good interview question. They often ask what application layer works at, which basically what is the layer number application layer work on. Okay, so it is 7th layer. After that, you will go and hit the presentation layer. And presentation layer has to do with the formatting. And what does formatting mean? For example, we have some images which are in a JPEG format. How this computer is going to differentiate JPEG format versus PNG format? So these all kind of formatting is going to happen on a presentation layer. This is also known as the encoding. Encoding, formatting, everything is going to happen on your presentation layer. Then this is 7th layer, this is 6th, and the 5th one is a session layer. Let's suppose we have one web browser running and we have multiple sessions going on, which is going to the same server, which is Google.
We do this every day, right, guys? Like everyone, Haifa and Crystal, we do this every day. We open a browser, we open multiple tabs. Sometimes even on, let's say, JobSkillShare or Google, you open many tabs to get to the same server, but you're asking for different information. And that's what the session is doing, because you're basically connecting to different sessions on that same application on the top. So you have this browser open, you're trying to connect using the 7th layer, then it goes to 6th layer because it may have images, we may have different images, it's doing presentation over there. And then you have multiple sessions that can be happening on that same browser by using session layer, using multiple tabs. That's just a little practical visual example, because again, it's not easy to present this, but that you do this every day, right? On your work machines and your home personal machines, right?
Mm-hmm. Yes.
Okay, so the other important aspect in the session layer is, let's suppose I give you example, if you have visited some the banking applications and you log in and you do some transactions. Usually application developers, they set some session information in your application, let's suppose for 15 minutes. Means your activity, if you are active on that website, this session layer will be activated and it will be like regenerate this number. But if you are doing nothing, after 5 minutes, after 10 minutes, you usually use this word, my session has been disconnected. So in technical term, this is called session tiering. Session has been tiered. So this is also another task of the session layer. So if your session is on, like in the Hotmail or Gmail, if your web browser is open and maybe you left that computer and you had no idea that you had to log out, after some time the session is going to expire and it will be logged out. So this is another functionality of this session layer. After that, we have a 4th layer, is the transport layer. The transport layer, we have two very important well-known protocols being used, TCP and the UDP. And the Crystal already answered this, that TCP and the HEFA as well. The TCP is basically the connection-oriented protocol, and UDP is connection-less. So can you answer me means, okay, this is connection oriented and this is connectionless. So what is the use? What is the purpose of these protocols then? Why can't we use just TCP or just the UDP? Anyone can answer, please?
When you, I don't know if this is what you want,
Okay.
but for TCP, we use, like, let's say you're logging into your bank
Okay.
online, you would use TCP. But UDP, you would use it to stream like Netflix and things like that, because if a
Okay.
few packets are missing, it's not going to make much of a difference. However, with
Yes, that's
TCP, it does make a difference. I don't know if
Yes,
that's
that's
the answer you were looking
Yes,
for.
exactly. This is what I'm looking for. So the TCP is connection oriented, where we need acknowledgements. We want to confirm that our end-to-end connectivity has been established with the help of, this is called three-way handshake. And I'm going to show this as well, three-way handshake. Okay, so what will happen in the handshake? The sync will be sent to the receiver, and the receiver is going to send back the sync ACK. Basically, it is saying that I have received your sync, and I'm going to acknowledge that. And then in the end, the ACK will be sent. This will be the final ACK. So this is how the connection will be established, and then whatever the transaction is going to happen later on, it will happen. But in case of UDP, we do not require these things. Why? Because as the HEFA said that we want to send the packet as soon as possible. If I give you a layman example of this, if we are watching a TV and you have come across with this issue so many times, there's kind of like some pixel lost during the, some broadcast, you are watching some movie or some like a match. Okay, so some pixel lost. So do you think that your television is gonna send back the acknowledgement to the sender that kindly send me that pixel again back to me? No,
No.
it doesn't require, it doesn't bother. So where we want to send the information as quickly as possible, we are gonna use UDP. And where we need the reliable, because reliability also a very important part of your networking. We want reliability on your web pages, because, for example, if I'm trying to access some web page like jobskillshare.org, and I just, in return, I just received the logo only, and the rest of the contents I haven't received, it doesn't make sense. That's why we're going to use TCP for the reliability.
So Kamran, I have just one question from a user perspective, and
Okay.
because we're on TCP UDP, I want to add it here so then it's gonna we have it remembered it. So as a network engineer, where do you get in and say, oh, I'm gonna make a decision for this type of network for TCP and this I'm gonna use UDP? Do we do this kind of stuff as a network engineer? This is coming from a person who's gonna be like, hey, why do I need to know about TCP UDP now? Am I gonna be actually working on this, or is this because just for troubleshooting?
Okay,
right?
so
Like if I'm a new person, now I'm thinking, as a network engineer, I got my job. Okay, I got a Cisco switch and router. Infrastructure is getting ready. Now where do I really need to know about this? Right?
Okay.
Is this for purpose of knowing how technology works and how these different things work? But do we, as a network engineer for Christelle and Hefa, can you tell them like why you really need this at this point? Like what would be the practical thing? I know it's going to come later on, but let's just talk a little brief on that.
Okay. So as a network engineer, to be very honest, we have not to worry about these protocols, TCP and UDP, other than the concepts and the troubleshooting. Because most of the application, let's suppose if we talk about the Skype okay, and then this Zoom, they are using kind of UDP application behind the scene. Okay, so in case if this application is not working, we have to troubleshoot UDP, whether the UDP port in a subsequent slides, I will show you what port the Discord is using, what port of the UDP of this Zoom is being used at the back, and maybe at a firewall, in a firewall, because this is going to be beyond this this lecture, but no problem. I'm just going to give you a little information. Let's suppose we have a firewall, and I hope everybody familiar what firewall is.
Yep.
Yes.
Because this is very common in your even it is not even hardware. You can consider it like the application firewall. Usually we have the hardware appliances firewall as well. Just assume we have application firewall. So in this application firewall, the chances are somebody has blocked the port for Zoom, which works on top of UDP. Let's suppose Zoom is using port 5124. This is just assumption. And somebody has blocked this UDP port. So you as a network administrator need to troubleshoot what is going on. And you must have an idea, first of all, what is UDP. And only then you can go and troubleshoot. If you are not having any distinction between TCP, UDP, you're not going to solve this problem.
Thank you for giving that example. So hey, and Christelle, this is why the reason I asked this question, just to give you some kind of remembrance of how important it is. Even if this is not something you're going to go and oh, I can see TCP or I can see UDP or I can practice on it like that. It may not be like that, but it's like understanding of it. If you don't know what kind of applications are working on what type of ports and how do you then go back and check it, then of course your troubleshooting as a network engineering is very hard. Because most of it is going to be a call related to something like this, where things are getting blocked, things are slow, or things are being used a lot. The bandwidth is too much, so you will have to kind of what do you do? Like you have to hunt down these things by knowing or understanding these different type of protocols.
I have a possibly very stupid question. So I'm sorry if this sounds really dumb. I know that in your example, you used Zoom and it being on port, whatever, 5124, whatever. I know this is just an example, but let's say they blocked the ability to use Zoom. Would WebEx meeting work on that same port? Like, would it have, if you block one port, are you also going to block any application that uses that one port? Or can you just specifically block?
No, every application has its own well-known port.
Okay.
Yeah,
Okay.
so if you block that specific number of port on a network level, then yes, it would block it. But again, it depends on that port is if it's running from that server, because like listen, if we have a one web server with a port 80 and I block that port on that server, then yes, on that server anything with that port 80
all the web, yes, exactly.
Yeah. And if we block the port 80 on a network level, this means everything, meaning port 80 is being blocked, guys. You guys cannot use it. Doesn't matter who you are, what server, it's going to be blocked for everyone. Does that make sense?
Yes, that's perfect. Thank you.
We're going to learn about these ports a lot in detail, let me tell you, in the CCNA. So you don't have to worry. So just, I'm just scratching the surfaces. You have basic idea what we are doing and where we are going to go in the future. Okay, so get the basic concepts here. And by the way, your question was very good. We have some well-known ports. We have some random ports in computer. Basically, we have from 0 to 65,535 ports available in our ports, of which we have 0 to 1, 0 to 4 ports are the well-known ports. These are kind of dedicated ports are allocated, like for example 80, 80, 443. These are allocated for HTTP and HTTPS. Let's suppose if you block these all ports, nothing is gonna work on your web browser. Your Facebook will be blocked, your YouTube will be blocked. So this is gonna happen. Okay, then we have the random ports which will be allocated by your computer to your source machine. So I don't want to discuss, otherwise you will be confused. I will go very quickly, but just get the idea that if we are blocking a well-known ports like this 80 something, even Skype has some well-known UDP port. You can search out, and if you block that one, Skype will be totally blocked in your computer.
Okay, that makes sense. Thank you.
Okay.
And just a tip, guys, when he say we will discuss this later on, remember you guys are still in Network Plus course right now. So he's trying his best to kind of scratch things, give you examples. But I also told him not to go extreme deeper because that is what the CCNA is going to cover. So we don't want to bombard you with, like a port, and then let's get into some really deep port type of stuff. So this way you will learn in a kind of like a chunks. Does that make sense? So it doesn't become like at one point, oh, we just jumped into something very deep immediately. So just understand this whole flow. That's how it's going to work. Network Plus slowly is going to get into more deeper, and CCNA is going to be extreme Cisco stuff. Okay.
Yeah, I think I like that.
Okay, let's move on. The other layer is network layer, and your CCNP, even the CCIE, 70% of your work is going to happen on this network layer. Day and night you will be troubleshooting network layer. So this is very important layer, and it has to do with the IPs. That's post IPv4. And why we use network layer? If I give you analogy of your, let's suppose we have the service provider, not service provider, but the cloud, which is internet. Here we have one sender machine connected with this, and the receiver is connected with this. Now, the user typed www.google.com. It went to application, presentation, session, transport layer. And now, once it will hit the network layer, which means what is the best path my it's gonna take the best, which one is going to be the best path. Whatever the communication is going to happen, it's going to take some path. When we talk about the clouds or the internet, just think like 1,000 and 1,000 of routers interconnected with each other. If I give you example, let's suppose this is our internet cloud, and I'm going to send information from my sender to receiver, and these all routers are connected with each other. In some fashion that there is a redundancy. And what redundancy is, if one path or the router or the path is lost, we still have the reachability from the other path. So other than redundancy, we should also have the best path. Okay, we want to reach to our destination, but with the optimal way. Let's suppose this is going to be our optimal way. So this is going to be our optimal path that basically comes under network layer. That's it. A lot of routing protocols we're gonna discuss in a CCNA and even in a Network Pro as well, like RIP, OSPF, EIGRP. These are very advanced concepts. Just I want to hit here just to get you familiar that at a network layer, we basically looking for a best path and nothing else. Okay.
Okay.
Then we have a data link layer. And let's say this like 40% or even 50%, we're gonna work on data link layer in a CCNA and CCNP and even the CCI level, because the switches works at data link layer. If you're not familiar with the switches, we are going to discuss a lot in detail in the subsequent videos. So basically what happens, a switch does nothing but just switch the packet. Whatever it received at its one port, it's gonna spread to all other ports. That's it. Whatever the information it is receiving, it is sending from the other side. This is what switch does. And switches use a very important concept. This is called MAC addresses, which we are going to learn later on. With the help of MAC addresses, it is going to communicate. So these all things happens at a data link layer. And then last but not least, the physical layer, which is nothing but all about your cabling. Because we need to connect our this sender device with the receiver somehow with some cable. So we need some physical, kind of mode we require. So at this layer, your data will be sent in a bits and bytes. So let me talk about the PDU. PDU is a general term used for this all packets or whatever you call it, data. So the PDU, protocol data units, is the term used for this data. But you can clearly see at application, presentation, and session layer, this PDU is called a data. But when this data hit the transport layer, this is called segment. Similarly, at network layer, it is called packet. And maybe you have heard this often that, my packet is transferred from this location to that location. It means they are talking about the network layer. If they are saying my frame is stuck somewhere, my frame is not moving, my frame has been stuck or choked out, it means they are talking about a data link layer. And the bits bytes worked on a physical layer. So far, so good. Anyone has any confusion?
And in network engineering level, when you talk to another network engineer, the way he was explaining, that's how they're gonna talk, and that's why you need to know about these terms. And yeah, it takes a little time. That's the whole purpose of this whole course. He's gonna keep doing it, keep telling you all this stuff, but that's how a network engineer talks to another network engineer. They don't go into just very basic stuff. They're just gonna talk, oh, the packet, yeah, the frames, yeah, this stuff. So you see why sometimes when we talk to a network engineer like this, we get a little confused because their language is a little different than us. That the reason for that is that they know this because they can break things down easily that way. They don't have to say every time transport layer or session layer. They may just say data, and you already know that he's talking about the three, 7, 6, and 5 right there, right? So that's a language that also try to kind of go back and kind of like just remember these little terms that he's talking about, because that's how they're going to ask you into.
Okay, and even in a CCNA questions in the exam, they will trick you into thinking that, or they will put the question like they will not talk about transport layer. They will be saying the segment sent from this location to that location. So it means he's talking about the transport layer. So this is what he wants to check the level of your thinking, that what you are thinking at this moment. If he is talking about segment, it means they are talking about the transport layer. If they are talking about the packets, it means they are talking about the network layer, the routers. And if they are saying the frames, it means the data link layer or the switches. Okay.
So I have a question, and
Yeah.
again, sorry if this is silly.
No problem. No, but keep asking.
But okay, so the first, sorry, 7, 6, and 5 are data layers. Would they mention data layer and then you have to guess if they're talking about application presentation?
These are 765.
Yeah.
Okay.
So if a question mentions the data layer, is it going to be, I guess it's depending on if they're talking about like,
if they are talking about the data,
they're gonna break it down in a way that they may say, this is a web browser, it went to this website, it used this application, what layer number has this used? Or they may say, this is a website with an image, so what kind of, when you send this image to another machine, what layer did it actually touch, like the number? So you would say layer 6.
Right.
If it says, that website that you just opened and it just got disconnected after 5 minutes, what happened? Which number did it hit? Oh, that's the 5th, right?
Yes.
Correct me if I'm wrong, Kamran.
Yes, you're right. Okay, this is sender and this is receiver. And when sender will send the information to receiver, some process is going to happen, which is known as encapsulation. In the next slide, I will demonstrate, but just I'll fly by overview. I'm just going to give you here. This is called the encapsulation, and here, when receiver will receive the packet, all the steps it will go through. It is gonna de-encapsulate here. I will just type de-encaps here. Okay, so what is encapsulation? How on earth these layers gonna know what is my next layer with the help of encapsulation? And what encapsulation is nothing. It will add, for example, here we have a data, and the data could be like your www traffic. It is gonna attach a header information, which is basically mentioning what layer I'm going to face next. So that's why we used encapsulation. Once it has reached a physical layer on other end, now it is going to de-encapsulate, because it is moving one by one to the receiver. So it has to remove this all, whatever it has quoted here. Okay, if you didn't get, the next slide is going to clear this. So let's move to the next slide.